Okay, sir. I think we should start now. Good audience is with us. Sir, you are muted. Please unmute your mic.
Yes, sir. Yes. Now,
Yeah.
am I audible?
Yes, sir. You are now audible.
Thank you, sir. So, very good afternoon to all present here. I, Dr. Prakash Singh, Associate Professor of Mathematics in the School of Basic and Applied Sciences, on the behalf of Anand International College of Engineering, Jaipur, would like to welcome Professor Praveen Agrawal, convener of the FDP, and Vice Principal, Anand IC, Jaipur, India, Dr. Meher Chand Sir, Department of Physical and Mathematical Science, Baba Farid College, Batinda, India, and dear participants. Today is the second day of the faculty development program on the topic of scientific computing essentials with MATLAB, a comprehensive one-week FDP. The FDP is jointly organized by Anand International College of Engineering, Jaipur, and Math Tech Thinking Foundation, Fazilka, India. Today's our speaker is Dr. SWAPNIL Viswanath KALE. Dr. SWAPNIL Viswanath KALE is an accomplished academic and researcher specializing in numerical analysis, scientific computing, and high-performance computing. He currently serves as the assistant professor and head of the department of the mathematics and statistics at CT Bora College, affiliated with Savitribai Phule, Pune University. Dr. KALE completed his PhD in applied mathematics from the Defense Institute of Advanced Technology, Pune, where he focused on fictitious domain method for solving complex elliptic and parabolic problems. With experience as a postdoctoral research associate at the Indian Institute of Science, Education and Research, Trivandrum, he has contributed significantly to high-performance computing projects related to cardiac electromechanics under India's National Supercomputing Mission. His extensive research portfolio includes several publications in reputed journals and numerous presentations at international conferences. Dr. KALE's expertise extends to machine learning, image processing, and algorithm development, making him a versatile figure in both academic and applied mathematics domain. So now, I would like to invite our first speaker, Dr. SWAPNIL Viswanath KALE, Assistant Professor and Head of the Department of Mathematics and Statistics at CT Bora College, India, for this session on the topic of advanced data structures and control flows. Please, sir.
Thank you, sir, for a wonderful introduction. Thank you, and thank you, Meher sir, also, and thank you all the organizers, both Anand International College of Engineering and MTTF Foundation. So, should I start, sir?
Yes, sir. Yes, sir. You can start.
Okay. Is my screen visible?
Yes, sir. Your screen is visible.
Okay. Good morning, all of you. Today I will present advanced data structures and control flow in MATLAB. In Scientific Computing Essentials with MATLAB, a comprehensive 1-week faculty development program, which is jointly organized by Anand International College of Engineering, Jaipur, and MathTech Thinking Foundation, Fazilga, India. The outline of my presentation is, firstly, I will present some little introduction about MATLAB, which is already presented by Dr. Preeti yesterday. Then I will introduce some relational operators in MATLAB. Then I will go for some arrays in MATLAB. I will introduce how to initialize arrays, address the arrays with colon, some basic operations with arrays, and indexing and slicing in arrays. Then I'll go for some advanced concepts of arrays, in particular multidimensional arrays. And then after that, I will go for advanced data structures in MATLAB. In that, I will introduce cell arrays, structures, tables, categorical arrays, sparse arrays, map containers, and I'll little introduce object-oriented programming in MATLAB. Then I'll go for control flow statements in MATLAB. In that, I'll introduce if statements, if else statement. Then I'll introduce some switch statements, for loop, and some nested loops in order to have a good programming and in an efficient way. Then, as we know that MATLAB is a computational software from mathworks.com. It is a easy algorithm development compared to existing languages like C, C++, or Fortran. It is a handy one for the people who know little programming, for scientists and engineers. And as we know that MATLAB is the abbreviation of Matrix Laboratory, and it is a high-level language purely based on C and C++. Its background codes are written in C++. This is the MATLAB in which command window is there, the workspace is there, and command history is there. As yesterday, Dr. Preeti has explained that if you require any help regarding MATLAB, you can also type help and that topic in the command window. And suppose here I want to introduce help inverse, then I can just type help of some inverse matrix, and then it will give me some output like this. Then, as Dr. Preeti already explained, how to create and run a script file in MATLAB. This is just for the audience purpose, which the slides I will share after the presentation. Then relational and logical operators in MATLAB. There are some relational and logical operators in MATLAB. First one is greater than, with the usual greater than symbol. Then less than, greater than or equal to, less than or equal to symbol. For equal to, we put double equal to symbol in MATLAB in our program. And for AND operator, we use ampersand. For OR operator, we use vertical line, and for NOT operator, we use tilde symbol. Then arrays are the collection of data values organized into rows and columns, and they are known by a single name. Arrays are nothing but the fundamental units in MATLAB. In fact, all the scalars are nothing but arrays, and this dimension are one row and one column. In MATLAB, rows and columns indices starts from 1, and arrays are classified into vectors and matrices vectors are arrays with one dimension, matrices are arrays with more than one dimension. And size of an array is specified by the number of rows by number of columns, and the number of elements in arrays are the product of number of rows in an array and number of columns in an array. Then some basic notes about variables in MATLAB. In fact, compared to other programming language, in MATLAB, every variable is by default an array. A scalar is an array with one element. A vector is an array with one row. And a matrix is an array with rows and columns. And if you are working in C or C++, each time you have to define a variable before calling it, and you have to define the type of that variable. But in MATLAB, you can directly call the variable without defining the variable prior to your code. And in MATLAB, once you define a variable, you can change its size even after defining the variable, or even after you use the variable in the upper code, you can modify that variable in a lower segment of your code. And this is not possible in other lower level languages. Then further, scalars can be changed even to vector, and vectors can also be changed to a matrix. And this is the biggest power of MATLAB, and this is the biggest advantage of MATLAB over other programming languages. And whenever you change anything in the variable, actually in background, that change is being done in an array corresponding to that variable. Then, if you have to initialize the variables in statements, you can directly initialize those variables in a command window. For example, is my screen visible? MATLAB screen? Please, someone confirm. Hello. Hello. Is my screen visible?
Yes, sir, visible.
Okay, thank you for confirmation. And MATLAB is visible, correct? Okay. Suppose you have to initialize array. Suppose you have to initial an array. Here in this code, I have initialized an array in the editor window, that I am writing this MATLAB code for a matrix. A is equal to the first row 1, 2, 3, 4. Second row of the matrix. Here semicolon is given in order to change the row of a matrix. Then 5, 6, 7, 8, and 9, 10, 11, 12. This is the matrix. So here you can directly initialize the an variable in a MATLAB. Then the number of elements in every row of an array must be the same in order to there should not be error in MATLAB. And the expressions used to initialize arrays can also include algebraic operations and all or of portions of previously defined arrays. Means with the help of previously defined arrays, you can redefine your arrays. Then here are some shortcut expressions to define an array. Suppose the first expression is x equal to initial value to final value. Then suppose I have to initialize an array x is equal to 1 to 10. Then I get an array, a row vector, with the gap between any two entries is just by 1 by default gap. 1 to 10. Here I am getting 10 entries from 1 to 10. And the gap between each entry is 1. Suppose I want to specify the gap. Let's say I want to redefine the variable x like this, 1 with the gap of 2 between two entries, 1 to 10. Then I am getting the vector x like this, 1, 3, 5, 7, 9. Then there is a command linspace with from the starting number, end number, and the number of entries you want between the vector. Again, I am redefining the variable in MATLAB linspace from 1 to 10, and let's say I want 5 entries in between these two numbers. Then I am getting 5 numbers between the number 1 and 10. Sorry. Now further, if you do not define the number of entries here I have given the entries 10 I want to define. But here, if I do not specify the number of entries there, then it will by default calculate 100 points between 0 and 1. For example, let's say I just use the command x is equal to linspace from 1 to 10, and I do not provide it here that how much entries do I want. Then it will calculate 100 entries by default. Then logspace command is there. Logspace command calculates logarithmically spaced row vector starting from the number start to number end, and it gives the number of entries in between them. For example, this command, I say generate vector is equal to logspace of 1, 2, 3 and 10. It will generate 10 points. The number specified here, it will generate 10 points between the number 10 raised to 1 and 10 raised to 3. For example, x equal to log space 1, 2, 3 and 10 numbers in between these. So it is giving, in fact, from 1 to 10, and the numbers are spread by the logarithm. And if you do not specify here I had already specified 10 entries, so it gave 10 entries here. But if I do not specify the number of entries, then it will by default generate 50 points for log space. For example, I type x is equal to log space 1, 2, 3. Then it will calculate 50 points from the initial point to final point. I will clear my screen. I am clearing all the variable and clearing my command window. Then some built-in functions for matrices. Suppose I want to generate a zero matrix of n rows and n columns. Then the basic command there is, suppose I want to generate a matrix, let's say B of size 4 by 4. I will give a command B is equal to zeros 4 by 4. Then it will create a matrix of number of rows 4 and number of columns 4. Let's say this is square matrix. Suppose I don't want a square matrix. I want some matrix of all the entry zeros with 4 rows and 4 columns. Then I will give a command B is equal to zeros of 4 rows and 5 columns. So it will generate a matrix. Here you can see that there are 4 rows and 5 columns. Then suppose you want to generate a random matrix of m number of rows and n number of columns. Then there is just a simple command. Let's say B equal to random numbers, and I want to matrix of entries matrix of size 4 by 4. Sorry. Then here I want to visualize matrix, so I am not giving a semicolon. So here I am getting a random matrix of size 4 by 4, where the entries random numbers are being generated by MATLAB by itself, and these entries are between 0 to 1. Suppose I want to generate a random matrix whose entries are from 1 to 100, then I will simply multiply by a rand command by 100. B is equal to 100 times random 4 by 4. Here you can see that now our random entries are from, if there are any arbitrary entries, they are between 1 to 100. Then suppose you want to generate an identity matrix of size m by m, means square matrix. Then there is a simple command B is equal to, B is your variable name, EYE for identity matrix, and just give a size. Suppose you want to give a size 3 by 3 identity matrix, then this is a identity matrix. B is equal to EYE of 3. This is the identity matrix of size 3 by 3. Suppose I want a diagonal matrix, then I can, suppose I want a diagonal matrix with diagonal entries or same 3, 3, 3. Then I can generate a matrix B equal to 3 times identity matrix of size 3. Then I am getting all the diagonal entries equal to 3. Let's say suppose I want a identity matrix of size 3 by 4. Then I will give a command b is equal to identity matrix of size 3 by 4. It will generate a matrix like this. Means in fact identity matrix is always a square matrix in our usual sense, but here it will generate a matrix like this. So then suppose I want a matrix whose all entries are 1 and I want a square matrix of this type. Then let's say b equal to ones of size 4. It will generate a matrix of size 4 by 4 whose all entries are 1. This is the matrix. Let's say I want a matrix of size 4 by 4 whose all entries are 5. Then I can write b equal to 5 times ones of 4. Ones of 4. Then I'm getting all the entries like this. Here you can also specify like this, b equal to 5 times ones of 4 by 4. You will get the same results. That's 4 number of rows and 4 number of columns. Whenever you give here single entry like this, MATLAB will get to know that here number of rows and number of columns are same. Let's say suppose I want a matrix of size 5 by 4 whose all entries are 1. Then simple command is b equal to ones. This letter should be small. MATLAB is a case sensitive. B is equal to ones of size 5 by 4. This time I will get a matrix of size 5 by 4 whose all entries will be 1. Here you can see that 5 number of columns are there and 4 number of rows are there. Done. Okay. Let's say now in MATLAB, as we know that finding inverse of a matrix is a very difficult task in any programming language. Like if you want to find inverse of a matrix in a C programming or C++, those who have done the program or wrote a program in C for inverse of a matrix, they might know that how much difficult that task is. But in MATLAB, you get an inbuilt command to find the inverse of a matrix. Let's say, first I'll clear all my variables in workspace and I'll clear my screen. Let's say my matrix is A is equal to 1, 2, 3, first row. Second column is 4, second row is 4, 5, 6, and third column is 7, 8, 9. Let's say this is my matrix and I want to find inverse of this matrix. Then just a simple command is there in inv of that matrix. Then I will get inverse of that matrix like this. In fact, here the inverse of this matrix is becoming very large because this matrix was here MATLAB is giving warning since matrix is close to singular or badly scaled, because in MATLAB do not do any calculation exactly. Actually, it uses some approximations. And this matrix is not well conditioned, so it is using some approximations, and that's why it is giving warning us that these results may not be that much accurate. Let's say our matrix is a good one. Let's say diagonal 1, 3, 0, 0, 0, 3, 0, 0, 0, 2. This is all we know that is a diagonal matrix, and its determinant should be 18, and its inverse should be all we know that its inverse. Then its inverse of this matrix is equal to this one, 1 by 3, 1 by 3, and 1 by 2. Here also you can see that results are approximated, not exactly, because I have given here short command, means by default it is MATLAB is calculating with 4-digit accuracy. So 1 by 3 is approximated by 0.3333. If I give a format long for MATLAB, then for the same inverse will look like this. Then here MATLAB will calculate the entries up to accuracy for 8 digits. I will again go for a short, and then again I will get the same result like this, like previous. Then matrix powers. Suppose you want to find any power of matrix. Let's say I want to find the square of that matrix. Simple. Already we have matrix stored in our workspace. So we are already having the matrix here. Suppose I want to find a square of our matrix, then simply a square will be like this. Suppose I want to find fourth power of this matrix, then I will do a raised to 4 like this. Then suppose we want to find a determinant of a matrix. Let's take the same matrix A, which is already stored in our workspace. A is equal to diagonal matrix, and we want to find determinant of this matrix. Then simply there is a command determinant of A for this matrix. Then I can get the determinant. As we know that determinant of this matrix should be 3 into 3 into 2. It means 18 should be there, and we are getting the same results. Okay, as here we can see that our matrix A is very nice. It is a diagonal matrix. Suppose I want to change any entry of this matrix. Let's play around this matrix A. Suppose I want to change this entry of matrix to 2. Let's say, then I can simply give or change here variable. It is a suppose I want to change the entry of first row and second column. I want to make it from 0 to 2. Let's say, then I can simply specify A of 1, 2 is equal to 2. Then our matrix becomes like this. See, here our matrix has been changed. Again, I will change in the same, do some changes in the same matrix. A of third row, first column, I want to make it 5. Okay. And again, I want to change some A of third row, second column is equal to 4. Now, this matrix is not that much nice. And now we want to find determinant of this matrix. I will just give a command determinant of A. And here I will get a determinant of this matrix. I think this matrix is diagonalizable, and we are getting the same eigenvalues of this matrix. So we can again play here around this matrix. Here the determinant is getting 18. So I'm guessing that the eigenvalues of this new updated matrix should also be 3, 3, 2. So we can also check that part, eigenvalues of this matrix A. So I'm expecting the eigenvalues of this matrix should come 3, 3, and 2. Let's check. To calculate the eigenvalues of this matrix, the command is eigenvalues of A. Yes, we are getting the eigenvalues as 2, 3, and 3. So, in order to find eigenvalues of any matrix, the simple command is EIG of A. That means, let's say A is equal to this matrix, and I want to again do some changes in this matrix A of 2, 1 means second row, first column. I want to make this matrix worse. Let's say 11, and again I want to make A of 1, 3 is equal to, let's say, 0.3. Okay. Okay. Now I want to find determinant of this matrix. See, this is a little bit complicated matrix, and we are getting the determinant of this matrix with just a single command, and eigenvalues of this matrix also we are getting. And here we can also find inverse of this matrix by command inverse of A. And again, we can find any power of this matrix. Let's say I want to find third power of this matrix by A raised to 3. Again, I will clear all the variables in my workspace. Okay, so we have already seen how to find eigenvalues of this matrix. Okay. Again, many times in scientific computing, whenever you are working with numerical solutions of differential equations, you will require to find a diagonal of a given matrix. Let's say your original matrix A is, we can call from the previously calculated matrix only. Okay, this will not work because I had given enter command there. Let's say our matrix is A is equal to 1, 2, 4, 4, 8, 10, and 0, 1, 3. Let's say this is my new matrix. and I want to extract only diagonal entries of this matrix. Then there is a simple command DIAG, short form for diagonal, and it is a keyword in MATLAB. DIAG of a given matrix, diagonal of A, it will give a diagonal entries of this matrix. Let's see here diagonal entries are 1. We are getting that we are extracting 1, 8, 3. So for a given matrix, we are getting a diagonal entries of a matrix 1, 8, and 3. Now, as here we have seen that for a given matrix, we can change its entries, we can modify its entries, we can find its determinant, we can find its inverse, we can find its eigenvalues, we can find any power of that matrix. Now, my target is to find eigenvectors of given matrix. Let's say my matrix is this 1 to 4, 4 at 10, and 0, 1, 3. And I want to find eigenvectors of this matrix. Then there is a trick to find eigenvectors. Let's say D equal to D be a diagonal entries of this matrix. D is another variable, diagonal of A. Okay, D equal to diagonal of A. I'm extracting diagonal entries of this. Then if I want to find eigenvectors of matrix A, then there is a command in a square bracket. Let's say V be our collection of our eigenvectors, V comma D is equal to eigenvalues of A, EIG of A. Then here you can see that V is here D is a diagonal form of a given matrix, and this V in a matrix form you are getting the first column of matrix V is a first eigenvector, second column of V is a second eigenvector, and third column of V is the third eigenvector. Means here, as our eigenvalues of A are, what happened this? Okay, now matrix is different. Here our eigenvalues are 10, 0, and 1. So corresponding to eigenvalue 10, the first column 0.2579, 0.9575, and 0.1290 is an eigenvector. So corresponding to our eigenvalues, we are getting 3 eigenvectors for a given matrix. So again, I want to revise. If you want to find, let's say in order to revise, I will take a simple matrix as a diagonal matrix. I will clear first all the variables in our workspace. Let's say our matrix A is a diagonal matrix. Let's say 2, 0, 0, 0, 3, 0, 0, 0, 4. Here A is a diagonal matrix, and we know that eigenvalues of this matrix should be 0, 3, and 4, and we also know the eigenvectors of this matrix as it is a diagonal matrix. Okay, correct. Now we will check that whether we are getting correct eigenvectors or not. Let's say D equal to diagonal entries of our matrix A. Then I will give a command V comma D is equal to EIG of A. Then we are getting the same 1, 0, 0 is the eigenvector corresponding to first eigenvalue 2, 0, 1, 0 is the eigenvector corresponding to a eigenvalue 3, and 0, 0, 1 is an eigenvector corresponding to eigenvalue 4. So for a given matrix, any matrix, we can play around it for in all the calculations corresponding to our linear algebra course. Now, many times in scientific computing programs, you will require to find a size of a matrix. For a m by n matrix, size is number of rows by number of columns. Let's say, I'll clear all variables in my workspace and clear my screen. Let's say A is equal to 1, 2, 3, 4, 5, 6, 7, 8. Again 1, 4, 5, 7. Let's say this be my matrix. Then the size command, size of A, gives a size of that matrix. Means size of A gives first entry is number of rows and second entry is number of columns. Then for a given vector, let's say x is equal to 1, 2, 3, 4, and I want to find a length of this vector. Here the vector x is short, so you can get to know the length of this vector by default. But in actual real life calculations, your vectors will be too big. So in order to find the length of a row vector, there is a command length of that vector, and you will get the length the length of this vector x as 4. You can also use a command size for x, and you are getting x is a row vector, means 1 row and 4 columns will be there. So the size of x is 1 by 4. Again, I am trying a command length for a matrix, as our matrix is 3 by 4 matrix, and I am trying the command length of A. Here, okay, there was some typing error. And then I'm trying a command length of A for our matrix A. Then I'm getting a 4. Means you are seeing that the size of A as 3 by 4, but length of A is giving value 4. Then what is the meaning of a length for a matrix? Means for a given matrix, length of a matrix is the largest value between the rows and columns. Means if my matrix is 3 by 4, here my matrix is 3 by 4, so length of my matrix is 4, because 4 is the largest value between 3 and 4. Suppose my matrix is like this: 1, 2, and 3, 4. Let's say I'm taking 3 columns and 2 rows: 1, 2, 3, 4, 5, 6. Then here size of this matrix is 2 by 3. However, again length of this matrix will be 3. Okay, the highest number between the number of rows and number of columns is called length of a matrix. Okay, here we have given for a matrix, length returns the largest dimension. Now a transpose vector. Here, let's say x is a row vector. If I take transpose of, for taking transpose of a vector, I will just say x prime. Then I can convert a row vector into a column vector. Similarly, for a matrix, let's say my matrix is this one, and I want to take transpose of this matrix. I will just give a command a prime, and I will get a transpose of this matrix. Then let's say I have 2 vectors. I will clear all variables from the workspace and redefine a vector x. X equal to 1, 2, 3, 4. This is my one vector. Y equal to 4, 5, 6, 7. This is my another vector, and I want to find a dot product of 2 vectors. Then to find a dot product for 2 vectors, there is a simple command called dot x comma y. This will give a dot product of 2 vectors dot of xy. Suppose someone wants to find a cross product of these 2 vectors. Then there is a command cross of x comma y. Then okay, I think here size of matrix is not compatible. I try cross product of x prime with y, so that transpose. Oh, still it is not working. I think undefined functional variable, spelling of cross. MATLAB, okay, there was a problem. Our variable x is this one, y is this one, and I want to find a cross product of these 2 vectors. Actually, the spelling of cross was CROSS. MATLAB is both case sensitive and spelling sensitive. So the keyword for cross product is CROSS, cross product of x comma y. Then okay, for a cross product, a and b must be of the length 3 in dimension. Okay, I will try x prime with y. Okay, not working. Then I will try x prime. Okay, still not working. Okay, I will see into this letter. Some size issue is there, I think so. Cross CRO double S. Okay, we'll try this letter, and or we can go into help option. Okay. Now, the biggest advantage of MATLAB is the matrix indices in MATLAB starts from 1, not from 0. This may not be advantage, but this is a point to remember. As we know that in programming languages C or C++, the counting starts from 0. The first entry of any vector or array in C or C++ is 0. However, in MATLAB, the first entry starts from 1, not from 0. And again, in MATLAB, the matrix indices must be positive integer. They cannot be negative in order to call those. Now, use of colon in MATLAB for vector. Here, I have given some code use of colon sign in arrays. Let's say here, okay, first I'll clear my all variable. Okay, now in this code I have written given a matrix A is a matrix of size 3 by 4, and I want to extract a second row of this matrix. First I will run this code. I will change the folder in order to run. Okay, now here the matrix A is this one, and I want to extract the second row of this matrix. Then I want second row and all the columns of the matrix. Then I will use this command A of 2, all the columns. Here we can see that 5, 6, 7, 8 is the second row, and we are able to extract it. Similarly, if you want to extract third column of this matrix, third column is a variable name, and it is equal to A of this colon starts for denotes it should consider all the rows, and third column means if I type A of colon, it will consider all the rows, and only now if I type here, it will give me only third column, means it will give me all the rows corresponding to a third column. So here again, this command is in MATLAB is if you want to display something in MATLAB, you just type this and some string in that. In MATLAB, string is typed in between the some quotes. In this quotes, anything is in MATLAB is considered as a string. So this of this string will give this type of code. Means here second row of matrix A is second row here already which was calculated, and third column of matrix is this one. Okay. Okay. Now again for a matrix, let's say okay, I will again run this code. Let's say this is A is a matrix, and I want to calculate find the entry in the third row and second column. Then I will just type A of 3, 2. I should get entry 10 that I am getting. Let's say suppose I want to extract all the rows of a matrix, but I want just columns, second column and third column. Then I will do like this. In this command, A of colon, this colon will consider all the rows, and here 2 to 3 means it will consider columns from 2 to 3, and 2 and 3 are included. Means here I am getting all the rows of a matrix and second and third column of a matrix. So these slides I will share later, and one may go through the slides. Similarly, if I want from this matrix A, I want second and third row and first and second column. Then I will give, suppose I want only this portion 5, 6, 9, 10. I want only these 4 entries 5, 6, 9 and 10. I want only this sub matrix of this array 5, 6, 9, 10. Then I will give a command to MATLAB A from second row to third row and first column to second column. 5 is in second row, first column, 6 is in second row, second column, 9 in third row, first column, and 10 is in third row, second column. Then I'm expecting the result 5, 6, 9, 10, which I am getting. Okay. Now in MATLAB, suppose you want to add element to an existing variable. Then again, here I have written a code for to add elements to the existing vectors or arrays. Here, this code I will share later. Again, suppose, let's say my V be a vector of vector 10, 20, or 30. You may avoid comma here. Comma is optional. Let's say this is my vector, and I want to add another entry in this vector at the end of this vector. Then I will just say V is equal to the square bracket V, and suppose I want to add entry 11 or let's say 40, so that one may not confuse. And then I will get result. Original vector was 10, 20, 30, and now I am getting 10, 20, 30, and 40. Suppose I want to add more entries, then I will just simply put 40, 50, 60, 70, like this. Suppose I have two vectors, let's say V already we have, and let's say W is equal to 1, 2, 3, 4. And I want to concatenate these two entries in another variable. Let's say Z is equal to, I want to concatenate these two entries or vectors. Then I will just do first Z is equal to V, Z is equal to V and W. Then I'm getting like this. The original vector V is up to here, and then I'm adding another vector 1, 2, 3, 4 to this like this. And in this way, you can add as much entries as you want at the end of a vector. I will again clear all the variables. Let's say, suppose again my vector V is equal to this one, and I want to add entries at the beginning of these vectors. I will again do V is equal to, again V, I want to add the entries at the beginning. Suppose I want to add 100 at the beginning, I will just do 100 and then original vector V is equal to this one. Here you can see that in the original vector, 100 is added at the beginning of this vector. Similarly, you can add multiple entries here, 100, 200, 400. Now again, here you will get to see the 100 two times, because here V is currently V stores the 4 entries, 100, 10, 20, and 30, and MATLAB will consider the latest available variable. Here you can see that 100, 200, and 400 we added it now, and in V already these 4 entries were present. Okay. Now we have seen how to add entries at the end of a vector or at the beginning of a vector. But suppose someone want to add some entries in a vector in between the vector, then here is a command or code I have written in order to add elements at the specific position. Suppose let's say U equal to 1, 2, 3 is a original vector, and I want to insert some element 10 at the position 10. Then let's say position is equal to 2. Then from 1 to that position, one vector minus, one entry minus, I will consider like this. Let's say we'll do here U is equal to 1, 2, 3. I will give a semicolon, or let's say U is equal to 1, 2, 3, and I want to add entry 10 at the second position. Then I will do, I will define another vector or a variable position equal to 2, and then I will redefine the variable U. U is equal to U of 1 to up to position -1. I want to keep U as it is. I will not change anything. And then then next position, at the position, I will add element 10. And again, I will consider U from that position to end. End is again a keyword in MATLAB. End of some vector is the last element of that vector. Then here what happened? U of some position -1 to U of position to end. U of 1 to position -1 10 position to end. Okay. Okay. There was error. Here you can see that the 10 is added here. Here you can see that we had done a mistake. Here we are taking U, this is outside, and which is not allowed in MATLAB. There was a syntax error from our side. I'll clear all the variables again. Go for the next topic. Okay. Adding elements at the beginning of vector we already done. At the specific position we did. Okay. Now addition and subtraction of arrays. This is already covered by Dr. Preeti in yesterday's topic. We all know that, let's say U is a some vector and V is equal to some vector. Let's say I will say U plus 1. Okay, this is not covered. V is equal to 4, 5, 6. Then simple addition of two vectors or arrays has been already done. But suppose we have a vector U and some scalar whose value is 4, and I want to add vector and scalar. Here U is equal to 1, 2, 3 and scalar is equal to 4. Then if I add U plus that scalar, it will add in every position. Means our original vector is 1, 2, 3. If we add vector and scalar, that scalar is added in every entry. Let's say 1, 2, 3. And if I add 4, this 4 will be added in every entry of this vector. Let's see here. 4 is added into 1, 5. 4 is added into 2, 6. And 4 is added into 3. It becomes 7. So if we add vector and scalar, it will get added in each individual entry. Let's say, suppose we have a matrix. Let's say A is equal to 1, 2, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 9. Let's say this is a matrix. And I want to add some entry 100 in this matrix. Then this 100 will be added in each entry of that matrix. Now matrix multiplication in MATLAB will be done as per the rules of linear algebra. Means the size of the number of columns in first matrix should be equal to number of rows in the second matrix. For example, if A is equal to the matrix 1, 2, we are already having it is in workspace. A is equal to this one. A is equal to this matrix, and let's say B equal to I will again I don't want to type and become some lazy. B equal to A transpose means we have matrix A like this and B like this. Then the matrix multiplication here, both are 3 by 3 matrix, so it is allowed here. Okay, but let's say our matrix A is equal to 1, 2, 3, 4, and matrix B is equal to 1, 2, 3, 4, 5, 6. Then A star B is not allowed. Then it is giving error, that incorrect dimension, because size of matrix A is 2 by 2 and size of matrix B is 3 by 2. So this matrix multiplication is not allowed as per the rules of linear algebra. Our variety matrix multiplication are always there as per our rules of matrix multiplication. Okay, this part I will not, I will skip this. Now I will cover some indexing and slicing arrays in MATLAB. This we already some covered. Okay. Let's say this is a program to study indexing and slicing of arrays. I will run this code. Just press F5 or click on here run button to run the code. I will again run the code. Okay. Let's say here, oh, what happened here? B should not be there. Okay, I'll clear all the workspace. One should always clear the workspace before running your new code, because what happens, the already defined variables creates problems for a new code. From here, okay, B is defined here, okay, for 2D arrays. Okay, correct. Here, let's say the indexing and slicing for arrays. First, I will explain indexing and slicing for 1D arrays. 1D array means just a vector. Let's say A is a vector 4, 2, 8, 6, 10, and I want to access third element of this. Of this here, A is equal to this vector. I want to access third entry of this. Then A of 3 is equal to 8. Similarly, I want to take slice or sub array of this. Suppose I want to extract elements of A from second element to fourth element. Just to command A of 2 to 4. I'll get 2 to 6. This is for 1D, which is very easy. Similarly, for 2D arrays, let's say here B is a 2-dimensional array, and I want to extract second row and third column entry. This is a command for that. And suppose I want to I just required second row of matrix B. I will use this command. And then I'm getting the second row of this matrix 4, 5, 6 is the second row of this matrix B. So indexing and slicing of arrays has been completed for both the 1D array and 2D array. This you can practice from this code as exercise. Now, the most important part we cover as a multi-dimensional array. Now, multi-dimensional array are very easy in MATLAB compared to other programming languages like C, C++ or Fortran. Because defining multi-dimensional array is a difficult task in order to extract elements or change the elements in that multi-dimensional array. In MATLAB, a multi-dimensional array is an array with more than 2 dimensions. A vector is an array with 1 dimension. Matrix is an array with 2 dimensions. But sometimes in practical problems or in data science or machine learning, you will require arrays with more than 2 dimensions. So, in order to visualize an array in 3 dimensions, you can consider this figure. A 3-dimensional array can be considered as a stack of matrices. Means one array behind that one matrix of 2 dimensions, behind that a stack of second matrix will be there, and in this way you can visualize an array in 3 dimensions. There are also arrays in 4 dimensions, 5 dimensions, 6 dimensions MATLAB, but they cannot be visualized. However, you can work with an array of any n dimension in MATLAB. Let's say, suppose again here, okay, this is the MATLAB program to study multi-dimensional array. First, I will clear all the workspace and clear my screen. Suppose, as we know that, let's say A is equal to zeros of size 2 by 1. Okay, this will be A is equal to zeros of 2, 1. This will be a 0 vector, column vector, correct? 2 rows, 1 column. Okay. Again, this is a 1-dimensional array. Z equal to zeros of 2, 2. This is a two-dimensional array, correct? Now I want to define a three-dimensional array. I will define A equal to zeros of 3, let's say 2, 2, 2. First entry is for number of rows, second entry is for number of columns, and third entry for number of sheets or stacks. Here you can visualize this array like this. Here 0, 0, 0, 0 is the first stack, then second stack, like this. Okay, this is a okay. Next, suppose I want to define a three-dimensional arrays with 3 number of rows, 3 number of columns, and 3 sheets. Let's say A is equal to zeros of 3 by 3 by 3. This will give output like this. I will make this bigger one. Let's see here. First stack of 3 by 3 matrix, second stack of 3 by 3 matrix, and third stack of 3 by 3 matrix. Let's suppose I change here z is equal to zeros of 3, 3, 1. This will give a matrix of size just 2 by 2. See here, this is our usual matrix. But if I do here change A is equal to zeros of 3, 3, 2, it will produce output like this. A first stack or first set of matrix of size 3 by 3 zeros, and second of size 3 by 3 like this. I will clear again this variable, all the variables. Okay. Again, now you have visualized a multidimensional array, at least how it will look like. But suppose you want to enter the entries of that matrix. First, I will initialize this array as A is equal to zeros of 3 by 3, 3, 3, means 3 number of rows, 3 number of columns, and 3 sheets of such matrices. Then I will fill array with some values. I have to fill these arrays. First, I will fill the first sheet as a first matrix. Then I will enter second sheet as a second matrix. Then I will enter third sheet as a third matrix. Now I will run this code. Then I will get the entire 3D array. After running up to here, we are getting entire 3D array like this. First sheet is 1, 2, 3, 4, 5, 6, 7, 8, 9. We are getting it correct. Second sheet is 10 to 18 entries. 10, 11, 12, 13, 14, 15, 16, 17, 18. And we are getting it correct. And next we are getting third sheet of this matrix. Then again, as you have visualized slices in 1D array and 2D array, you can also visualize slices in 3D array. Means in fact in 3D array, it is nothing but slice behind slice, behind slice, behind slice, like this. Here we are getting 3 slices. First slice is the first sheet, 1, 2, 3 means first matrix. Second slice is second matrix, and third slice is third matrix. Again here, similarly, as in 1D array or 2D array, you can access any element in 3D array. Now, suppose you want to access the element at position 2, 3, 1. What is meant by 2, 3, 1? Means second row, third column in a first sheet. Means A of 2, 3, 1 is the entry from the second row, third column from the first sheet, which is 6. We can see second row. What happened here? Second row, third column, and first sheet. Similarly, A of let's say 3, 1, and 2 means third row, first column, third row, first column, and second sheet. Its entry will be this one, 16. See here, 16. In a second sheet, third row, and first column entry is 16. So in this way, you can work with multi-dimensional arrays. Okay. Now I will start the concept of advanced data structures in MATLAB. The points up to here I covered. These points will be enough for those people who are working for numerical solutions for differential equations or working with linear algebra. But suppose someone is working with data science or machine learning or want to use MATLAB for real data or real life problems arising in data sciences, then you will require advanced data structures in MATLAB, and you are blessed with advanced data structures in MATLAB compared to other languages. Here, as MATLAB offers variety of advanced data structures that allow for more complex data management and manipulation beyond the basic arrays and matrices. As you have seen, the arrays, you can work only with numbers. But suppose someone wants to work with strings, means in advanced data structures, you can consider arrays with non-numerical values, means strings. You can work with, like English alphabet, suppose wants to work, means some data is there, some variables are there, and you want to work with that, then these advanced data structures are there. And there are various types of advanced data structures, and they are used for more sophisticated data manipulation and management. And the purpose of it is to make easier to handle complex data sets and perform advanced data analysis. In that, first is cell arrays. Cell arrays are versatile containers that can hold different types of data in each cell, including arrays of different size and types. As you have seen, let's say, suppose here, okay, I'll say A is equal to A of, this is not work because we have already clear variables from the workspace. Let's say A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Here you can see that A is a 3 by 3 matrix, correct? Here, the first entry means first row, first column entry is a single number. Similarly, second row, third column entry is a single number. But what if you can able to make this more interesting and more advanced one? In cell arrays, you can make the second row, third column as a string or as a matrix also, or as a any submatrix or collection of matrices. Means you can play as you want with some, obviously some rules of MATLAB. So for this, cell arrays are introduced. Suppose this is the basic diagram of cell arrays. Means this is a 3 by 3 cell. Here you can see that first row, first column is nothing but a matrix. First row, second column is some string. First row, third column is a single number. Second row, first column is again some single complex number. Again, second row, second column contains many numbers. Again, second row, third column contains single number or some matrix. Similarly, as in matrix or in our previous arrays, for a single entry, you could store a single number. But in a cell, for each subcell, you can store sub-arrays, arrays, or string, or any type of variable. This will get more clear once you see the actual code. this is the program to study cell arrays in MATLAB. First, you have to create a cell array. I will clear my previous variable and clear my screen. In order to create a cell, first the syntax is, instead of square bracket, you have to give a curly bracket on both the sides, and in between you can enter your variables. For example, suppose I want to make a cell like this. C is equal to a cell, a curly bracket. I want to prepare a cell of size 3 by 2. First entry should be 1. Second entry of this array can be a string, and as we know that string should be written in quotes. Then third entry, I want a matrix, or sorry, a row vector. Okay, this is the first row of our cell, and at the start of second row, first entry I want a value of pi. Second entry of second row, I want it as a matrix, and again last entry of our cell I want some string like this. I think what happened, some error is there. C is equal to 1. Hello. Okay, here again we have made some syntax error. As usual, we are habitual to work with usual numeric arrays. Here I gave a square bracket, but in order to define a cell, it should require a curly bracket, and MATLAB has suggested us. MATLAB is a brilliant software. Here it has also given an error, and it has corrected my syntax. Okay, so here we can see that this is a 2 by 3 cell. This is a 2 by 3 cell. The first entry is single element 1, first row, first column. Second entry means first row, second column is a word hello. First row, third column is a 1 by 3 double. This double is for the entries. This is a matrix of size 1 by 3, means a row vector, and whose entries are of type double, means with double precision. And then here we are getting the value of pi 3.1416 with 4-digit accuracy. Then again I am getting a 2 by 2 matrix with double precision, and again I am getting a word, the world. Now here you have defined the cell, correct? But now if you want to access the elements of a cell, the way you access the elements in arrays or matrices, in the same way you can access the elements of cell. Suppose I want to access the first row, second column element of a cell, then I can simply give, again here curly bracket should be there, C of first row, second column, and whatever is there I can get. See here, the element at the first row, second column of that cell is hello. Suppose I want to extract the element at first row, third column, it is a vector. See, interesting. Here, one entry is string, one entry is a vector, and again, suppose I want to extract element C of 2, 1. See here, it is a single entry, value of pi, and let's say C of 2, 2. It is a matrix. It is quite interesting. In a cell, some entries are numbers, some entries are strings, some entries are vectors, some entries are matrices, and some are any variable. So the cell arrays gives you more freedom to work with your real-time data. So with the help of cell arrays, you can work very much efficiently in order to do your data analysis job perfectly or in a more meaningful way. Again, similarly, the size command was there for a matrix in order to define the size of an array, correct? Similarly, you can give a size of a cell or extract size of cell C is a 2 by 3 cell, correct? Okay. Just checking, right now I do not know whether this command will work or not. As I'm just playing around it. In a matrices, you can take a transpose. I'm checking whether transpose is working in cell or not. Let's check. Let's say C transpose. Oh, it's working. Great. Means you can also take a transpose of a cell. Now I want to access the elements of cell. Let's say I want to access first, it is a 3x2 cell. So I want to third row and first column element of that cell. Oh, here curly bracket should be there. Square bracket is not allowed to extract the elements of a cell. What happens? Matrix size is, oh, it is C dash. Actually, it was a C dash. Let's say I will create a new variable x is equal to C dash. And now I want to extract the elements of x of 3, 1. Okay, correct. Now it is giving a vector. Correct. So, similar to the array of numbers, you can take transpose of a cell, and this is quite interesting. So, cells are very much useful to work with real-time data or any arbitrary type of data, but there is a condition. Let's say here C. Okay, C is a cell you have defined, correct? As similar, let's say, okay, since you know that in array, let's say A is an array. In array, let's say in a first row I'm taking 2 entries, and a second row I'm taking only 1 entries. Definitely we know that this is going to give an error, correct? Since in a matrix, number of elements in every row should be same, correct? It is giving an error. Similarly, in a cell also, this is a cell, the number of elements in every row should be same. Suppose I'm removing this element, then definitely this will give me, oh, what happened here? It should not be a square bracket, it's curly bracket. Okay. Now see, here I am definitely get to know that this will give me error. Again, same dimension of arrays being concatenated as they are not consistent, means similar to the array in a cell also, dimension means number of elements in every row or in every column should be same. Okay, so now let's say this is my array, cell array. In matrices, you can modify the entries of matrices later. Again, we will check that whether we can modify the entries of a cell array. Here, as we know that first entry of cell, our cell is let's say 1. And suppose I want to modify the first entry of our cell as MATLAB. Let's check. C of, oh, this will not work, no? C of 1, 1. I will make this as I love MATLAB. This is a string variable. Done. And now I am going to access the first entry of our cell array, first row, first column. And previously it was 1 just. Now the first entry of our cell is I love MATLAB. I will clear all the variables from my workspace and clear my screen. Okay. So cells are done. Similarly, here you can see that the more here, again we can see that this is a 2x3 cell. First row, first column is some matrix, and here again we can see that second row, third column, it is again collection of cells, collection of some subcells. Means cell is a very much versatile type of array. Means in matrix, as you know that you can have some matrices. Similarly, in cells you can have some subcells. Oh, we can also check. Let's say again I will run this cell command. Let's say I want to take slice of our cell. Let's say C1 is equal to some slice of our original cell C. I want to take original cell was of our 2x3 cell. I want all rows of my cell, redefining cell. I want all rows of my cell, but I want only second and third column. Let's check. I do not know whether this will work or not. Let's check. Okay, it's working. So here our original size of original cell was 2 by 3 and new cell C1 subcell of C is now 2 by 2, correct? And this is a subcell. Hello, 1 by 3 double that vector 2 by 2 matrix and that same word. So similar to the arrays of numbers, you can also play with the arrays of cells or cell arrays. So this is a very versatile, cell is a very versatile array and you can play around it, and it is a very interesting one, in particular for data science. Now, okay, this is all the advanced data structures will be helpful in the work of data science. This is the we have played. Next important type of array is structures. Structures are data structures that group related data using named fields. And here interesting fact is that each field or subfield of a structure can hold different types of data. Here, suppose I have data of some patients. Let's say I have data from some hospital, and here there are some patients, and I have some data of their names, some their billings, how much bill is there, and some their test. This matrix will denote some entries corresponding to some his medical test. So, in order to do data analysis of these types, the structures will be useful. Then, in order to define the structure in MATLAB, here I have written a code. Okay, here I have written a code to study structures in MATLAB. First, you have to create a structure. Here, you can directly initiate a structure. This is the actually advantage of MATLAB. In MATLAB, you can directly initialize variables with their name. You do not initialize the name, their data type and their name as you do in C or C++. You directly define a variable and give its value. Here, I have directly defined a structure whose name is patient. Patient.name means name is stored. The variable name is stored under the structure whose name is patient as a John Doe. John D is the name of a patient. Patient billing, his billing is 127, and here is some data of this. Suppose I want to create a structure of this type. Suppose I want to create a structure of this type, then I can write a MATLAB code like this. Means if I will clear all the variables from my workspace, and I will run this code. See here, this structure is defined here. See here, patient name is John Doe, patient billing is 127, and some patient data is there. Here again I have this is a display patient name command is there. Display patient.billing is there, display patient.test is there, and here test is a command, test is a some matrix. Here we can see that in structures, this structure is holding 3 different types of data. This structure whose name is patient, he is holding a data, it is holding a data of variable name, it is holding a data of type string. The second variable billing is holding a data of numeric data of float, and a third variable under the structure patient, it is holding a data of array. Means in a same structure you can hold different types of data. Let's play around the structure. Let's try something, or let's play something with this structure. I will type patient. This code has already been run, so I can directly type patient, and here I'm getting a patient is a structure. This struct is a MATLAB keyword. If you click on this, it will give you more information about this structure, and it has some field. It has a field name whose name is John Doe, billing 127, and he has given some test. Let's say I can also suppose I add another field under this patient.new is equal to patient is now recovered. Okay, this is string variable. Okay, patient dot new. Patient. Okay, correct. New is a. Again, if I run this code, again, if I then this new structure is modified, and then I'm getting a new variable under structure, and it is storing the value. Patient is now recovered. Now I can also, let's check. We can whether we can modify here. The billing amount is 127. Let's check whether we can now modify the billing amount after running the code. Let's say patient dot billing. Let's say we are reducing its bill to 100. Let's check whether it will work or not. Okay, I'll clear my screen and first we have to run the code. Oh, there was no actual need. Let's say patient.billing is equal to 100, and let's now see how our structure PAPIENT will look like. Patient is now recovered. Now here you can see that billing amount is 100. Here see that here billing amount was 127, but now here in command window we have modified the patient billing to 100 and it is changed to 100. Correct? If we clear all the variables here and CLC, then again we'll get the same billing amount 127. Okay. So in this way you can play around structures. So structures are very easy. Even compared to the cells, structures are very easy to play around it. Okay. If you have to learn these basic things in MATLAB, first I will share these codes to you. You can just play around these codes. You will get to know many things rather than studying or seeing other things. Just play around these basic codes. You will get to learn many things by just playing around this. Then structures have been covered. Okay. Then tables. Again, MATLAB has a very versatile type of data structure known as table. Tables are suitable for storing heterogeneous data, similar to database tables or Excel spreadsheets. Means, as in Excel, we can store various types of data. In a similar way, you can store data in tables in MATLAB. These tables might be quite useful to do data analysis of some clinical trials. Means the organizations who are working in clinical trials, they can use this data structure named tables to deal with the data of some patients. Here is some code. Again, I will explain the basic code of these tables. Okay. Here is a code of first I will clear all the variables from my workspace, CLC. Okay. In order to create a table in MATLAB, write a keyword table. Table is a keyword of a MATLAB. In order to create a table, T is a variable name. It can be anything. T is some table. Is a keyword, and then give a round bracket on both the sides, and in between enter your data. Here, this is some type of cell in a table. Sorry, this is some column. Let's run this code. Okay. Okay. Here, first, in a table, you enter the data. This is a string data, so written in a curly bracket, then some vector data written in a square bracket, and then you give a variable name. See here, table, this name, Sankej, Johnson, Lee, Diaz, Brown are in a first column. Okay, here they are in a first column. Then the second column, 38, 43, 38, 40, 49 is a second column. Then third column is defined here. Then fourth column is defined here. And then variable names for all these columns. The first variable is name, second variable is age, and third variable is weight, and fourth variable is height. Means here the sequence actually matters. Suppose if you give here name and here age, it will get mismatch. I will do here CLC. See here, this here it is giving age and here it is giving name. So the sequence is very important here. I will rerun this code. Now it is fine. Okay. Here this table is defined in this command only. Then in order to display the table, I will just use a command disp and that variable t. Now table is defined. Okay. Now if you want to access the variables in the table, suppose I want to access second entry in the variable name in the table t, then I'll give a command t dot name and I want to access second name. It is a Johnson. See, it is here is a Johnson, correct? Now suppose I want to access third entry in a third entry. Sorry, 8 minutes. Sorry. Here, firstly, we have access second entry in the name variable in a table T. It is Johnson. Now, suppose I want to know age of a Johnson. I will do T dot age Johnson. Here it is case sensitive. Johnson was on number 2. T dot age of second. So Johnson's age is 43. Suppose I want to find weight of a Johnson. T dot weight of 2. I will get 163 is the weight of Johnson, and we can check here Johnson, whose age is 43, weight is 163, and let's check whether height is coming to 69 or not. Let's check T dot height of Johnson. Johnson is on number 2. It is coming to 69, correct? So in this way, we can access the entries in the table. Same. Once you clear the arrays of numbers, you can work with cell arrays, structures, and tables. Here, in the similar way, we are accessing the entries of a table. Now, let's check whether we can change the entries of a table. Let's say I am running the code here. Here we can see that. Let's play around Lee. Here, Lee's age is 38. Suppose by mistake it is 38. Now you want to correct it. You want to make age of Lee as 58. You can also do it in command window, but it will not be get stored. So you can do T dot age of Lee is on third number. Age is equal to 58. Let's check what happens. I'm doing it for the first time. Let's check. T dot Lee is correct. The age of Lee has been modified to 58 from 38. I will remove this from here. Okay. And I will clear the screen. Okay. Oh, what happened? Okay. Correct. So tables are clear to you. I will clear the screen and all the variables. Okay. So you can play around the table similar way to the structures. Next, there are categorical arrays. Now, categorical arrays are used for storing data with fixed number of categories. And this is useful for representing and analyzing discrete non-numeric data. To handle numeric data, our vectors, matrices, and multidimensional arrays are good enough. To handle numeric data, there is no need to study these advanced data structures. But if you want to handle non-numeric data, then these advanced data structures are useful. And in that, if you want to handle discrete data, or you want to analyze, you want to do some analysis, you want to predict some output, then you can use categorical arrays. These categorical array are very fantastic. They are efficient storage container. They're easy to manipulate and they do meaningful analysis of some categorical data. Categorical data has important functions like count cats is inbuilt function, categorical, categories, and there are some visualization tools. As you have seen in a table, this table is an important function in a table in order to create a table, correct? Similarly, in categorical arrays, count cats, categorical, categories, and some visualization tools are important functions in order to analyze effectively the present categorical data. Now, suppose you have a survey of some fruits to some people that you want to predict which is the favorite fruit among the people, and you have some survey. Let's say that we will directly go to some code. Here I have written a code for categorical arrays. Okay, here someone has already done a survey and he has given some response. Response is a variable. This can be anything as a variable name. Someone has done a survey of some favorite fruits from some region or some society, and their survey contains some name of fruits. Let's say apple, banana, cherry, apple, and here we have considered only 3 fruits for a demonstration purpose. This data can be as huge as can. Then you want to analyze which fruit is favorite among the people, and this data is a discrete one, and it is not well managed. This is just a random data. Then you have to predict some output from this data. As a mathematician, we are happy with the play with the numbers, but as a data analyst, when you want to play around any type of variable, then this type of data structures are useful. Here, the data is not numbers, data is non-numeric, and you want to play around it. So categorical arrays will help you. So in responses, there are some non-numeric data. Then first, you have to create categories of given responses of a given variable this is a collection. Then favorite fruit is just a variable name. You can give any variable name. Categorical is a keyword of a MATLAB to create categories. Then categorical of these responses create categories of these 3 fruits. Then this command will display the favorite fruit. Then food counts is a variable name, and count cats is a keyword of a MATLAB, which I already explained. This categorical is a keyword, count cats is a keyword, and categories is a keyword. From these keywords, you can analyze your data. This categorical will categorize your data. Count cats will count this data of these categories, and these categories will categorize your data. Then I will visualize something this data. Okay. Now I will run this code. Okay. I will show you this further. Okay. After running this code, it has given a categorical. This all data is there: apple, banana, cherry, apple, banana, apple, cherry, cherry. So here you can see that this favorite fruit has just displayed this favorite fruits variable. Here, favorite fruit is a variable, and which is from the keyword categorical. So it has displayed all the variables, and further there is a command count cats. This count cats will count the categories of different categories, means how many apples are there, how many bananas are there, and how many cherries are there. So here it is given 3, 4, and 2. Means apples are 3, bananas are I think 3 and 2 are cherries, I think so. And this may not be in sequence format. Means one cannot guarantee that this 3 stands for apple, or 4 stands for banana, or 2 stands for cherry. This is just a category. Means it is just giving, in some category there are 3 elements, in some category there are 4 elements, or in some other category there are 2 elements. This category of maybe of any category. It is just giving number of elements in some category. And it is giving this fruit names categories will see all the responses and will not give, means how many types of data is there. In original data there are 3 types: apple, banana, and cherry. Means 3 distinct entries will it give. Means suppose here, let's play around this category array. Suppose here we enter another fruit. Let's say no, I'm thinking about lemon. Lemon is not fruit, but still just to play around it. And now I'll clear this. Okay, I'll not clear. I'll again run the same code. Now here, see that we are getting 3 fruits: apple, banana, cherry, and categories 3, 4, 2, and this one. Let's run this code. What happens? Let's see. What happened? Undefined. Lemon. Response: apple, banana, lemon. Okay, category response. Here also I have to edit. Then lemon. Here also I have to edit, I think so. Let's see what happens. I'll clear all the variables. Correct. See here. Now this gives my original responses, correct? The first column. Then what happened? Correct. Then previously this was just 3, 4, 2 categories, and now I added another fruit called lemon. It is given 1 category of it. Correct? Again, and again it is giving 4 fruits here. Suppose I again add here another lemon. Let's see what happens. So I expect this should become 2 and nothing other changes. And here 1 entry will be increased. Correct? And again I am running the code. See here. Number of lemons are becoming 2 by adding here lemon 2 times. Correct? So you can play around the categorical arrays. Suppose let's reduce apple. Here 1 apple here, and now we run, and let's also reduce. Okay, fine. Just to check, this is fine. See here. Previously apples were 3. Now apples are 2. Correct? So the corresponding changes are done here. So you can also play around these categorical arrays. Okay. Now further, MATLAB has also given the okay, just a second. Now the categorical arrays here in this command, we have visualized the categorical data with this code, and here we are seeing now the favorite fruit. The favorite fruit here. See here, apple, banana, cherry, and lemon. And so from this data, we can see that the favorite fruit is banana. Let's change something. Let's again add some more lemon, and let's check the graph. See here. Now number of lemons are increased here in data. So from these graphs, one can easily see that the favorite fruit among the surveying people or society is banana. So in order to do data analysis, the categorical arrays are very useful. Okay. Now, the very important concept of sparse arrays. The sparse arrays are blessings for the people who are working in actual scientific computing. In particular, the people who are working in the area of numerical solution of differential equation, sparse arrays are blessing. Due to the sparse arrays, your code becomes very much optimized. Means compared to the usual arrays, if you use sparse arrays, you will able to save lot of computational time. Means for some code, if 1 hour is your some system or computer is taking 1 hour to run with the usual arrays, and if one uses sparse arrays, if code is written in an optimal way, one can save up to for 15 minutes if one uses sparse arrays instead of usual arrays. So in sparse arrays efficiently store and manipulate large, mostly empty matrices by only storing the non-zero elements. So whenever you store any element in MATLAB, it takes some memory of your system. So many times in scientific computing, whenever you get numeric arrays, lot of entries of your matrix are zeros. So sparse arrays do not store that zero entries. It stores only non-zero entries. So it saves a lot of memory. And due to this saving, a lot of computational time has been saved. Now, instead of storing every element of the matrix, sparse arrays only store the non-zero elements and their indices. This leads to significant saving in the memory and computational efficiency when dealing with large sparse matrices. Suppose you are dealing with a matrix of size 1 million by 1 million entries. In that case, this sparse matrix significantly will save your computational time, computational memory, your power, everything. So in dealing with the real life problems, in actual problems, the sparse arrays are very useful and actually blessings. So key features of the sparse arrays, they are very much memory efficient and computationally efficient. MATLAB provides a special function to store a sparse arrays. And I will surely I will explain the sparse arrays in detail. Before that, I will explain the application of sparse matrices. Sparse matrices are extensively used by the mathematicians, engineers, and scientists. In particularly, the people working in the area of finite element methods, finite difference methods, finite volume methods, or any numerical method to solve boundary value problems or differential equations. Means whenever one wants to solve differential equation by some numerical scheme, sparse arrays play a very critical role to save a computational cost. Now we will see how to use the sparse arrays and take benefits from the sparse arrays. So here I have written a code for this sparse arrays. Before running this, I clear all the variables in workspace and clear the screen. Okay. Now, before explaining this code, I will, whenever you give a command z equal to, let's say, okay, I is equal to EYE of 3. It is identity matrix, correct? So here it is storing these non-zero elements also and zero elements also, correct? But whenever you give, let's initiate a command, yes is equal to sparse is a command to store sparse of 3. It will generate a 3 by 3 matrix of 0 entries. Then I can do s of 1 1 is equal to 1, s of 2 2 is equal to 2, s of 3 3 is equal to 3. see here now. Now here now S is a matrix whose first row first column entry is 1, second row second column entry is 2, third row third column entry is 3, and it has not stored other entries. S is definitely here identity matrix, correct? Or diagonal matrix? It has not stored non-diagonal entries. So it is very much efficient. So if I want to visualize full matrix S, oh, this is a small f, full matrix S, this is a yes. This is a full matrix S, but actually S is this one. So S is not storing other entries. So it is saving a lot of memory. So it is very much computationally efficient. Now, in order to define sparse arrays, let's firstly we define a variable rows, next columns. This is for in defining sparse arrays, you have to specify in a comment which entries you want non-zero. Sparse arrays by default it takes all the entries as non-zero. Sorry, zero. So you have to specify which entry should be non-zero to it. So it will store in his memory only non-zero entries. Suppose I want first row second column entry non-zero, third row first column entry non-zero, fourth row third column entry non-zero, and I want first row second column entry as 10, third row first column entry as 20, fourth row third column entry as 30. And I will create a 5 by 5 sparse matrix. This is the command. And S is equal to sparse of rows, columns, values, which corresponding to these rows and columns, it will store the values in this values column, values vector in that matrix. Let's run this matrix. For time being, I will put here semicolon so that I don't want to visualize it. Okay. I run this code. Here you can see that I am getting third row, first column entry as 20, first row, second column entry as 10, fourth row, third column entry as 30. Rest all entries are 0. We can visualize this by doing this. Full of yes. See here. Here all the entries are 0 and only non-zero. But in a sparse matrix, yes, it is storing only non-zero entries. Okay. So whenever you are actually working with numerical analysis of differential equations, one should always use sparse entries or sparse matrices instead of regular matrices. Next, there comes map containers. Now, map containers is a very useful tool to store key value pair. It is very much similar to the dictionaries in other programming languages. Map containers in MATLAB are very much flexible and efficient to manage key value pairs, and they have dynamic sizing. And you will get more clear once you see the actual code. So here, this is the map container code to study it. So corresponding to some keys, I want to define some values. So let's say my keys are variables are names. Let's names are Alice, Bob, and Charlie, and corresponding values are their age. Then containers is a keyword in a map. Here map is a containers.map is a keyword of a MATLAB to store or to modify the variables in map container. Then then names is a keys and ages are values, and corresponding to the names I want to map ages for these people, Alice, Bob, and Charlie. Then I'll create a variable people map, and containers.map will map these ages to these people names, and then I can access the elements by this. Age of Bob is equal to people map of this Bob is now named. So if I'll clear all the variables. I'll run this code. Okay. Okay, what happened? I think I'm short of time. Here map, it has count 3. 3 names are there, and value, the keys are character type. These are character types, strings are there, and value type is double precision. Numeric values are there. Then age of Bob, from this people map of Bob is 30. Suppose you want to find age of Charlie, then use PEO, people, variable name is people map of, and your key is a character of Charlie. Then you want the age of Charlie, and it should get reflect 35. What happened? See, spelling is mistaken. And you want to reflect the value as, still there is a problem. It's happening. Let's check. People map. People map of CHARLE. Let's see what happens. Oh, still it is not giving. The specified key is not present in this container. CHARLE is present actually. It is happening. Let's rerun the code. What's actually happening? Okay, let's see. We'll see it later. Okay, we'll modify it here. Let's see what will happen. We want age of Charlie, CHARLIE. Oh, R is missing, I think R. CHAR. Let's see. Yes, correct. So, age of RLIE is, so we are playing around this code. So, age of Charlie is, oh, still it is giving 35. Age of Bob, it is a previous map only. I think we have to clear the variable CLC, then it will be a correct one, because it was a already previous variable was stored. Correct. And then again, suppose you want to update the map, then you are updating some entry name alias and his age 26. You can also update the entries in map, and you can play around it. You can also study this map. I will share this code. I think we are out of bound time. Next, similar to the other languages, C and C++, we have object-oriented programming language or function in MATLAB. MATLAB supports object-oriented programming, and it allows you to define classes with properties and methods. The syntax and structure of MATLAB is very much simpler, and it is almost somehow parallel with the C and C++. And it is very much easy to use, and its performance is very good. But compared to the C++, MATLAB's object-oriented programming, in my opinion, is not that much great. In my experience, the object-oriented programming of C++ is good. Means I have good experience of C++ in this object-oriented programming. Then MATLAB also allows integration of object-oriented program features to its built-in rich data sets. And MATLAB is a high-level language and easy-to-use environment for specific scientific computing, rapid prototyping, and data visualization, and the performance is also adequate as per the needs. But if you want to use your programming as high performance computing, so always prefer C++ for fast results. Means you are concerned about computational efficiency So definitely that C++ will be better, because MATLAB in background will work in C++ only. So it will take more time than original language C++. Next, there are control flow statements in MATLAB. There are various types of control flows in MATLAB. Meher sir, may I take 10 minutes more? Okay.
Yes, sir. No problem.
Okay. Thank you, sir. So, control flows are very much useful in order to define or use your code for actual problems. The very basic control flow is a if statement. The basic syntax of if statement is if with some condition, there are some statements. If that statement is valid, code will go through this line only. If that statement is not valid, it will go to the another line. And again some condition will be there. Then some statements, again some. If the above two conditions are not satisfied, it will go to the next loop and it will satisfy the other condition and will end the statement. Now I will explain the if statement directly through the example. Okay. Now, suppose I want to check whether my number is greater than or 10. This is the program to study if statement. Let's run this code. Okay. First, I'll clear all the variables and okay. Let's say number is equal to input. Input is a function to take the input from the user. And if my number is greater than 10, then I will display the number is greater than 10. And if my number is not greater than 10, then nothing will happen. The code will not enter in this loop if my number is not greater than 10. Let's run the code. Enter your number. I run number 100. Then I know this number is greater than 10. So it is giving me output. The number is greater than 10. Here it is, if number is greater than 10, it is displaying the number is greater than 10. Suppose I will again run the code and I'll type the number 7, then nothing is happening. So it is not actually, the code is not executing. This code is not actually executing, because this code is executing only if this condition is satisfied. My number here is 7, so it is not entering to further lines. So whenever my number is greater than 10, it is entering into this line and I am getting the output number is greater than 10. Now, next, I will explain if-else if statement. I will again clear. Okay. Now, I will again ask some input from the user, enter your number. If my number is greater than 10, the code will go here. If my above condition is not satisfied or false, my code will go into this line and it will check whether this condition is satisfying or not. If this condition is satisfying, this part will be executed. And if this condition is also not satisfied, then this part will be executed. Let's run this code. Let's enter our number. Let's enter 12. So 12 is greater than 10. So first part will be only directly executed. Number is greater than 10. Let's again run code. Our number is 10. So first part is not true. Number is not greater than 10. So this part will not executed. Code will enter into this line and here this condition is satisfying. So code will execute this part and it will stop here only. So I entered number 10 and I am getting the number is equal to 10. Now, now if I enter number 2, now my number is not greater than 10, number is not equal to 10, then both the statements are false. So my code will run this part. So let's run it. I am getting output number is less than 10. So if else if statement is also clear, then switch statement is there. I will clear all the comma variables. Okay. Now switch is also a control flow statement which is very useful in particular for both numeric and non-numeric parts. Let's say the name of our switch is day. I will say day and I will ask from the user what day is today. If my day will satisfy this case, there is statement switch case end. If my day is satisfied, then this part will be executed. If this is not executed, it will get to this part, and if this up to this part is not satisfied, it will go to the option otherwise. As a general part of the switch statement, the switch is switch some expression, and then if this expression is satisfied, then this case is there, and again some statements are satisfied. Again, second case is checked. If this check is condition is satisfied, then code executes these statements, and if not, then otherwise statement. So here, let's run the code. Enter your day in string format, because our case we are considering are in a string format. So today is Wednesday. Today is Wednesday. So let's check what the output of the code. So it is the middle of the work week. See here. If case is Monday, then it will display output start of the week. If case is Friday, it will display the output end of the work week. And if not Monday, not Friday, it will display middle of the week. Our input was Wednesday, not Monday, not Friday. It is giving middle of the week. Again, I will run the code and I will enter the input Monday. Then it will give an output start of the week. Again, suppose I will give the input Friday. It will give end of the work week. So switch statement will be clear to you by this code. Next, for loops. For loops are very much important and they are very easy to understand. I will explain the basic. For some index is equal to some values and some statements will be executed and end statement is there. I will directly explain code for statement. Suppose you have a vector z is equal to this one 10, 20, 30, 40, 50, and you want to change each entry of this vector. Then, as explained previously, you can manually change each entry of this vector. Means you can change z of 1, z of 2, z of 3, z of 4, z of 5. This is possible if your z is of small size. But what if your z is of size 1 lakh by 1 lakh or 1 million by 1 million? You just can simply use a for loop. Suppose I want to add in each entry a number 4. Then I can simply take for I is equal to 1 to 5, since there are 5 entries 1, 2, 3, 4, 5. Then for index I equal to 1 to 5, z of I will be changed to z of I plus 4. And I will end here and I will display the output. So your original vector was 10, 20, 30, 40, 50, and you have added 4 just by a simple code, just by a 1 line or 3 line code in all the entries of a vector. This can also be used for matrix or cells, or for categorical arrays. Everywhere this you can use. So for loop is clear. Then while loop. For while loop, there is a syntax while some condition is satisfied, then some statements are executed and end. Now, for programmers, there is always chaos between choice of for loop and while loop. Which loop should be chosen? Both the loops, most of the times, serve the same purpose. Again, the same we want to add the number 4 in each entry of the vector z with the help of while loop. While some condition I is less equal 5, z of I equal to z of I plus 4, and I have to modify. This statement is very much important while loop. If you do not use this while loop, this statement I is equal to I plus 1, this may go into infinite loop and it may crash your laptop or system. So always be careful, very much careful while using while loops. While loops are sometimes risky for your system. You have to be very careful, because when it go into the infinite loop, it will be a problematic for your system. If you do not use this line, it will not get, I will not increase, means I will be always equal to 1. So this loop will work infinite number of times, and your code will never stop. It will always be running and running. So always be careful in running while loop. So again, I will run this loop and I am getting the same output. So while loop also serves the same purpose as of for loop, but I will suggest to use for loop instead of while loop. Then break and continue statement. Here we will use break statement in the for loop. Break is used to exit a loop permanently. Most of the times what happens, while loop, you get stuck in a while loop and it will create a problem for your system. So in order to break or come out of that loop, you have to use a break loop. And similarly, continue statement is there. I will explain both the things in a by code directly. Break. Suppose I want, let's in this, for I is equal to 1 to 10, there are, again, if loop is there inside the for loop. This is a nested loop. For I equal to 1 to 10, I want to display this output. But whenever I will come to the file, I want to break to the code. Whenever I will become a file, I want my code should get stopped. So let's run the code. So here you see that actually I was running code for I equal to 1 to 10, but due to this loop and break statement, whenever my I becomes 5, my code is getting stopped at I equal to 4. After that, it will not getting executed anything. So this is about break statement. Now I will explain continue statement. Again, same break and continue statement serves more or less the same purpose. Again, for I equal to 1 to 10, when mod is a MATLAB inbuilt command to check whether number is positive or negative. If number is positive or negative, if modulus of that number is 0, then I will continue. Means if my number is even, I will continue. But if my number is odd, I will stop. So I will run. Okay. Oh, it is actually reverse. Whenever I will be for even, it will skip. Whenever my number I will be even, it will skip my iterations, but it will continue for odd iterations. So see here, due to this command, this is continued only for odd numbers. So our only first iteration, third iteration, fifth, seventh, and ninth iteration is executed. All even second, fourth, sixth, eighth iterations are skipped. So this is the use of continue statement. Next, nested loops and control statements. For practical problems, you have to use nested loops, means loop inside loop, for loop inside for loop, if loop inside if loop, or if loop inside for loop inside if loop. You have to nest the things. So I will explain it by actual code. So here, it is a simple code. For I equal to 1 to 3 and for j equal to 1 to 3, I will display some I, j, ij, and this output. Similarly, if statements are executed, we'll run this code and you will get output. For this first half, for this code, we are getting the output I as a numbers to string is a for. The numeric values are converted into string. This is a MATLAB inbuilt command. So for loop inside for loop. Here we are getting I equal to 1 also. Means whenever I is becoming 1, this loop is executing 2 times. Means for j equal to 1 and j equal to 2. Again, this loop goes to the I equal to 2. Then this loop again get executed for 2 times. J equal to 1 and 2. Again, this loop goes for I equal to 3. Again, this loops, inner loop, j equal to 1 to 2 runs 2 times. Similarly, if loop. Again, there is a if loop inside if loop. Whenever you will play around these loops, you will get more clear. And you please play around this course. I will share with you. And then a very interesting code. After that, I will conclude this code as a nested code for a matrix point of view. Let's say we want to generate a matrix, a sparse matrix for practical problems of any arbitrary size of your choice and with respect to some physical parameter depending on your physical system or engineering system. Let's run the code and we'll see. Let's run the code. Enter the size of your physical model matrix. Let's say for time being, we'll see 5. You can take 1000, 2000, anything. I just want to display the result 5. And let's say enter the parameter of your physical system. I will choose 0.2 and I will get a matrix with the help of this for loops. For I equal to 1 to n minus 1 and diagonal entries I am taking 2 by h. Upper diagonal entries I am taking minus 1 by h. And lower diagonal entries I am taking minus 1 by h. And I am taking A as a sparse matrix. So I am not storing 0 entries. It is only taking non-zero entries here. So this becomes my A matrix. Zeros are not stored. And if I want to we want to visualize our whole matrix A, which is a command full of A, and see here. These 0 entries were not stored here. Diagonal entries are 10, upper diagonal minus 5, lower diagonal minus 5. Again, I will run this code for bigger matrix. Let's say size. Let's say we'll take 8 size 0 point physical system 0.5 and C. F is this one, full size matrix, and your matrix is this one. 4, 4, 4, minus 2. Diagonal entries are 4, upper diagonal minus 2. Okay. So we are almost done here with MATLAB. And as we have learned a lot of MATLAB, so why not to say thanks in terms of MATLAB code? I first clear my screen, all the variables. And in order to say thanks to all my lovely audience for paying the kind attention, I will run this MATLAB code and I will say thanks to all of you through MATLAB only. Thank you so much. This was from my side. Please, if you any queries, please, I will be happy, very much happy to say.
Dear participant, if you have any kind of question, you can put your query. Session is open for discussion. Also, you are permitted to unmute your mic.
Yes,
Yes,
sir, yes.
you can unmute your mic and put your query.
Yes,
Either
thank you, Prof.
Yeah, please. Yes, please.
Yes, thank you so much for today's presentation. It's also a very excellent one. I so much appreciate it. Well, my question borders on the use of MATLAB for data analysis, as the presenter has done some elementary part and the coding part. How do you import data from maybe Excel? Because generally, we don't store data on MATLAB so that the data on the Excel can be explored in the way he tried to explain using the programming ideas. I don't know if my question is clear. Then can also one use MATLAB along with some other computational tools? I am very much used to using Maple. Okay. Also, these days, the general thing is to use Python. Yeah. I mean, is there a way that you can explore using other programming tools along with MATLAB, because MATLAB is more technical for most of these calculations. Thank you.
Sir, please unmute your mic first.
Thank you so much, Dr. Nico, for your lovely feedback. Actually, in order to import the data from Excel, you can definitely import the data from Excel in MATLAB. So there might be some commands, MATLAB inbuilt command to import the data. Those right now I do not remember, but you can directly Google the commands, and you can definitely import the commands. And definitely, MATLAB is a very good software in order to do data analysis, and lot of MATLAB community is working in that. So you will definitely find some course related to Excel sheets to do data analysis in MATLAB.
Any more question, please?
Hello.
Yes.
Good day. This is Dr. Ahmed Audu from Department of Statistics, Usman Danfodio University, Sokoto.
Yes, sir.
My question is simply, you have been talking about mathematics since morning. I've not seen any demonstration on application of a MATLAB to statistical problems. Can we apply MATLAB to solve statistical problems, just like we have XPSS, Minitab, R, and other softwares? Thank you.
Yes. We can definitely use MATLAB for statistical applications to do the data analysis. But to do purely statistics, there are some good softwares like R programming is definitely there, and there is a SAS statistical analysis software is there, which is almost similar to MATLAB and which is I think little bit costly. It is totally devoted to MATLAB. Sorry, it is SAS is totally devoted to statistical analysis. So in MATLAB, you can definitely do statistical analysis, and you can do in a very good way. But SAS is definitely a better platform to do statistical analysis.
All right, thank you.
Yes.
I think there is no more question. Please, sir, unshare your screen.
No. One other question, Prof. I want to know, is it all version of MATLAB that works with all these methods that he had given? Because my version of LAB 2008, it's for some of these packages. I don't know if it would work, or maybe one has to find the latest MATLAB for use. Dr. Diko from Mathematics Department, University of Bora. Thank you, sir.
Thank you, sir. Actually, I'm not getting audio was a little bit trouble, so I'm not getting. You can text me or mail me, sir, please, because I will. Mayor sir will mail give you my mail ID, sir. Or you can put a question in chat box, sir, please.
Dr. D.A. Diko, your question not properly audible. Can you please text us?
So I think in chat box, Ahmad Adu has raised one question. Comma is missing before pi. Whenever you enter a row vector in MATLAB, comma is optional actually. It is not compulsory. You can either give or you can ignore it.
I have sent the message to the chat box. Can you see it? I have sent the message to the chat box.
Just a second. In the slicing of vector, how can you augment missing or incomplete values? In the slicing of vector. No, whenever you take a slicing of, how can you augment missing? You can augment it with the help of colon only. That part I explained here. With the help of colon only, you can use it. See here, just a second. See here. See here. Here we can augment element at any given position with the help of this type of code. You can augment it. Once you go through this code, no, you will get an idea of augmenting it. You just have to use colon in a brilliant way. With the help of colon, you can index or slice anything in MATLAB or augment any entry. Is it clear, Dr. Diko?
Very nice and impressive presentation, Dr. Swapnil. I think Dr. Diko has dropped his question. It's just above it. Okay, his question is it all version of MATLAB that works for all these computations? Actually, he's having an old version, 2008. So this is his exact question. Could you please answer him?
In new versions, it is not a problem actually. The versions are above 2016, it will not be a problem.
I think there is no more question, and it is clear, Dr. D.A. Diko. And if still you have any kind of
thank you.
Yeah, if anyone have
Thank you.
some question, you can text us, or also you can put in the feedback form. Okay, in the coming, we will give you the option to submit your queries, your prompts also. I hope this session is very informative, knowledgeable to all the participants, and the content which are being presented here really very helpful. And in the coming sessions, these will be very helpful. And also the matrix operations which we discussed today, all these will be very helpful for the data science, data analysis, even in the part of machine learning, deep learning. And when we do some numerical solutions, in that case also these content which are presented today will help you to understand the visualization of the graph and the results, and to how we can get the numerical solutions of any kind of mathematical models. So first of all, thank you, Doctor, for your nice presentation.
Thank you so much, sir.
Please unshare the screen.
Screen is shared, I think.
Yeah, thank you very much. So this is the certificate of appreciation for this wonderful session.
Thank you so much, sir.
Yeah, to Dr. SWAPNIL V. KALE, Department of Mathematics and Statistics, City, Bora College of Arts, Commerce and Science, Pune University, Pune. He has delivered a talk on advanced data structure and control flow at the Scientific Computing Essential with MATLAB, a comprehensive one-week faculty development program held from 24 to 28 June 2024. We deeply acknowledge and are honored for his exemplary contribution as the keynote speaker. This program is jointly organized by the Anand International Engineering College, Jaipur, India, and Method Thinking Foundation, Fazilka. So once again, thank you, sir, for your contribution in this session.
Yes, sir. Thank you so much, sir. Thank you so
much. And also, we will request you to provide the entire content.
Yes, yes.
So that we can provide this content to all the participants. They are asking for this content. Yesterday also, we were not able to provide these. So the participants are very eager to learn more and more by attending this session. And these content also will be very helpful in the coming session also if they do some hands-on practice. And also, dear participant, it is mandatory to all the participants, the feedback form we are sharing in the all the WhatsApp group, as well as I am sharing today's feedback form in the chat box. So please submit it. Along with the, there is some quizzes we are sharing in the WhatsApp group. So please do all these assignments so that you can complete, and after that you will have the certificate of participation. Just 1 minute, I am sharing the, where is chat box? Okay, you will get the feedback form in the chat box and please submit it. And one session, we have 2 days more, but 3 sessions. So we have to organize 2 sessions one day. Tomorrow there will be 1 session, but on the last day we have 2 sessions. So accordingly, we will update you about the 2 sessions. So 1 session will be at the same time, and the timing for the other session will be updated through the WhatsApp group and through the email address. So once again, thank you to all to join this session, and tomorrow we will join at the same time. And meeting link will be also will be shared with you.
1 minute for the audience, sir. Sir, 1 minute. Yeah.
Yes, please.
I will share you the presentation on all the MATLAB codes to you. You please share to all the audience. And my appeal to audience, all the people is that please play around the MATLAB codes, which I will share. Then while playing around those codes, you will get to know more and more. And thank you so much, sir.
Thank you, sir. Thank you. Thank you to all. Now it is